Okay, so the next problem that we might run into when trying to do the simplex method is that we have that negative constant that we were talking about. Um, so if I look at what the graph would look like for this one, we see that my actual feasible region is not going to contain the point 0, 0. Now, whenever I have a system of equations or inequalities to begin with, what it's going to show me is an equation that is going to correspond to the point 0, 0 whenever I put it into the tableau, because these two lines are not going to have that form where I have just a 1 with zeros in that column. All right. So in order to fix this problem, because I'm not even on my feasible region yet, is I'm going to perform what is called a fixing pivot. All right. So we've kind of skipped straight down, but if I were to put this into a tableau, here we go. All right. So if I want to perform a fixing pivot, my pivot row is going to be a row with a negative constant in it. So I can pick any row with a negative constant in it. And my pivot column is going to be a column that contains a negative entry in the pivot row. All right. So I have negative entries in this row, and this has a negative entry in this column. So I can pivot off of this element if I want to fix it. All right. So here I'm going to perform my fixing pivot on row 2, column 2. This is the matrix that I would get if I were to put this guy into my calculator and perform the pivot program on element in row 2, column 2. So here's what I would get. Now notice, none of these are negative anymore, which means that I am on a feasible point. But it's not optimal because I still have negative entries that are in this section of my matrix. Okay. So I need to perform an optimizing pivot, which means I'm going back to my regular rules. Okay, so what we've done up to this point is just get this into the form of a problem that I can use the simplex method on, as it was in section 6.2. Now that I've done that, I'm going to look through here and I'm going to find what pivot I should do based on the simplex method. Now this is more negative than negative 11/3, so I'm going to choose this one. And if I were to make ratios here, the only non-negative ratio would be this 3/2. This would be 3/2, but this would be a negative number. So I would end up with a pivot off of the 2. I'm going to pivot off of row 1, column 1. And again, if this were in my calculator and I ran my pivot program off of row 1, column 1, we are going to pivot to this matrix. And that will give me an optimized solution because none of these are negative anymore. And reading it the way that we have in all of the previous sections and videos, this means x1 equals 3 halves, x2 equals 3 halves, s1 equals 0, s2 equals 0, and finally 1 equals, or z is going to equal 39.